So let's talk about the odd and even identities for hyperbolic functions. Recall that hyperbolic functions are defined as follows. Sinh of x, which is sometimes called hyperbolic sine, or sin h, equals e to the x minus e to the negative x all over 2, and cosh of x equals e to the x plus e to the negative x all over 2. And tanh of x equals sinh of x over cosh of x, which equals e to the x minus e to the negative x all over e to the x plus e to the negative x, if we rewrite it in terms of exponentials using the definitions of sinh of x and cosh of x. So sinh of x is an odd function, meaning that the identity sinh of negative x equals negative sinh of x holds, and cosh of x is an even function, which means cosh of negative x equals cosh of x. This is similar to the negative angle identities for trigonometric functions. Sine of negative x equals negative sine of x, and cosine of negative x equals cosine of x. There's also an identity for tanh of x, which is tanh of negative x equals negative tanh of x, which means tanh of x is also an odd function. So here's how we prove the first identity. We start with sinh of negative x and plug in negative x into the definition of sinh of x. So sinh of negative x equals e to the power of negative x minus e to the negative of negative x, and then all of this is divided by 2, since sinh of x equals e to the x minus e to the negative x divided by 2. So the e to the negative x term becomes e to the negative and then parentheses negative x. So if we simplify this, this becomes e to the negative x minus e to the positive x, since negative and negative cancel out, and this is all over 2. We can factor out a negative 1 and rewrite the expression as negative parentheses e to the x minus e to the negative x all over 2, and you can see that this expression is equivalent to the previous one, since if we distribute the negative back into the expression, the numerator becomes e to the negative x minus e to the x again. Well, we can see that e to the x minus e to the negative x over 2 is just sinh of x. So this means this expression is just equal to negative sinh of x. So we started off with sinh of negative x, and then we ended up with negative sinh of x, which means we can confirm that sinh of negative x is equal to negative sinh of x. So the proof for the identity cosh of negative x equals cosh of x is quite similar. So we start with cosh of negative x and plug negative x into the definition of cosh of x. So this becomes e to the negative x plus e to the negative parentheses negative x all over 2. And this just simplifies to e to the negative x plus e to the x all over 2. Well, if we rearrange the terms, this can be rewritten as e to the x plus e to the negative x over 2, and this is just exactly the definition of cosh of x, which is e to the x plus e to the negative x over 2. So this just equals cosh of x. So we started with cosh of negative x, and we ended up with cosh of x. So we have confirmed that cosh of negative x equals cosh of x. So to prove tanh of negative x equals negative tanh of x, we need to use the definition of tanh of x involving sinh of x and cosh of x. So if we start with tanh of negative x, this is just equal to sinh of negative x over cosh of negative x. Well, the numerator, sinh of negative x, is just equal to negative sinh of x using the identity we just proved earlier. And cosh of negative x is just equal to cosh of x, as we also proved earlier, so the denominator is cosh of x. Well, we can isolate the negative sign outside of the fraction and rewrite this as negative of sinh of x over cosh of x. And sinh of x over cosh of x is just tanh of x. So this is equal to negative tanh of x. So we started with tanh of negative x and we ended up with negative tanh of x. So tanh of negative x equals negative tanh of x. So now let's talk about hyperbolic functions in terms of even and odd functions. The definition of an even function is that f of x equals f of negative x for all x, and an odd function is a function where f of negative x equals negative f of x for all x. Since sinh of negative x equals negative sinh of x is an identity, which means that it's true for all values of x, sinh of x is an odd function. We can see from the graph of sinh of x, which has rotational symmetry about the origin, this is a feature of odd functions. Since cosh of negative x equals cosh of x holds for all values of x, cosh of x is an even function, and we can see this is the case from the graph of cosh of x, which is symmetric about the y-axis. If we consider the tanh function, tanh of negative x equals negative tanh of x, which we proved earlier. This means tanh of x is an odd function, and we can see this from the graph of tanh of x, which has rotational symmetry about the origin. So to recap, sinh of negative x equals negative sinh of x, cosh of negative x equals cosh of x, and tanh of negative x equals negative tanh of x. So this also means sinh of x and tanh of x are odd functions, and cosh of x is an even function.